All right, guys. Measures of central tendency. This is where we're going to talk about mean, median, and mode. And then we will talk about it. Yeah, so that'll be easy review. Okay, we call these measures of central tendency because they represent a typical or a central entry of a data set, okay? And mean, median, and mode are by far the most common measures of central tendency. Now, we need to make sure we have straight what each one is. If I ask you to find the mean of the ages of each one of you in here, how do you do that? There you go. Add it all up, divide by how many people are in here. If we have 36 people in this room, I would take each age, add them together, divide by 36. Now, because you guys are all seniors in high school, at Terrell High School, are your ages pretty close to each other? Yeah, I can calculate your average or your mean age, but that's a lot of work to do that. There are times it's really good to be able to calculate a mean or an average of something, and there are other times it might not be the best way to do it. Now, here's where we start in learning some Greek letters. And the first one we're going to talk about is the letter sigma. Have you seen these on anybody's shirts before? You had friends go off to college, join a frat or a sorority. Yeah, you're going to see a lot of these letters on a college campus. Sigma is a summation sign. Listen. Sigma is a summation sign. If you're summing things, what are you doing? You're adding. So when you see this sigma x, it means you add together all the data entries in the set, all the x values. Now, to get your population mean, all right, one more time. What's the difference between a population and a sample?
Population is a whole sample.
Population's everybody. Sample is a small part of the population, or just a portion of the population. So if I want to get the mean of a population, my formula is that I add up all the x values and I divide by the number that's in the population. And they're using a capital N to represent the number for the population. But this is the part I want to point out to you. Anytime we are dealing with a population value, they're going to use a Greek letter to represent that. I know that kind of looks like a U, but it's sort of a funny looking U, would you say? It's got a longer tail on the left. That's because it's the lowercase Greek letter mu, mu, okay? So your population mean is mu, and it's equal to the sum of the x's divided by everything in the population. Now, if I'm only working with a sample, would I still find a mean the same way? Add them all up and divide by how many's in the sample. But look at how the formula looks different. The only thing that changes is instead of using a capital N, now we use a what? The lowercase n. And the lowercase n is the clue. This is being used with a sample because it's not everybody in the population, it's just a portion of it. And then the symbol that represents this formula, because it's from a sample, not a population, will not use a Greek letter. This, we would say, is X bar, because there's that line on top of the X. And that's what we use if we want a sample mean, a mean from the sample, okay? You will have to work to get the notation down. That is a huge part of statistics, is making sure you can identify what the formulas mean. And if they're written with these Greek letters, you got to know how to read it. All right, so heads up on that. Okay, questions then on the mean. You know how to calculate it. This will tell you whether you're working with the population or whether you're working with a sample. Now, here's a question. The price in dollars for a sample of round-trip flights from Chicago to Cancun are listed. Can you find the mean price of the flights? And you say yes. So I'm going to give you a second to do that. Again, you want to make sure you got a calculator. This would not be a lot of fun to do without one. And so notice, is this a sample. So my formula for mean involves the X bar, not the mu, but it still just means I add them up and divide by, how many are there? 7. Very good. Okay. Whenever you've got the correct answer, let me see hands so I know how long it's taking. All right, got a few of you. So you've calculated the mean. What'd you get?
I don't want to say.
You're not confident, Daniel. Okay.
Not on this one.
Okay. You got what? $527.86. Anybody else get that? Ah, see, you got some people. Wait, let's see. All right, did you get 3,695 when you added them up?
Yeah.
And if you divide that by 7, because that's how many was in our list, they rounded, I don't know why, to 90 cents, but I think 86 cents is actually more accurate, isn't it? 0.86. Yeah. So if you were $527.86, you're right. If for whatever reason you rounded to the nearest dime, it would be $527.90. Makes sense? So as long as you've got a calculator and I ask you to find the mean of something, you can do that, correct? I am confident you can. Now let's talk for a second about the median. Because the median, I don't add things up and divide by anything. How do I find the median of something?
Put at least the greatest.
Exactly. Put them in order from least to greatest, and the value I want is which one? The one in the middle. Okay, you guys drive. When you're going down a highway and there is something in the middle to separate the 2 lanes of traffic, that's called a median. It's in the middle. So your median means I want the middle number, and I've got to put them in order from least to greatest to find it. Now, as long as I have an odd number of items in the data set, like the one we just looked at had how many different prices? 7. A minute ago, Daniel was showing if you've lined them up, basically you throw out the lowest and the highest, and then you would chip away until you get to the middle. And as long as there's an odd number, it's going to be one of the items in the list, right? Okay. So what do you think happens if it's an even number?
You have to take the average.
There you go. Then I would be left with 2 entries in the middle, and I have to average those together. And that will be my median, which means it could be a value that's not in the data set if those were 2 different numbers. Okay, so let's go back to those same flights, but this time, instead of telling me the mean, I want you to see if you can tell me the median. You think it's going to be the same? I don't know. Let's see. So in order to get the median, you got to do what with these values? Put them in order from least to greatest. So you put which one down first? What's the smallest one? 388. Then you put 397. And then you got 397 a second time because it shows up here and it shows up here. Then you put, what would be the next biggest after 397? Looks like 427, 432. And then, yeah, I got a couple of big ones, 782 and 872. Okay, I do not think I'd want to pay $872 for a ticket if I could actually get one in the 300s. All right. So what would you tell me is the median? Because when they're in order, that's the one that's in the middle, right? Right there. Because I can throw out the highest and the lowest, then the next highest, next lowest, and I'm going to be left with 427. That's a different number from the mean. Isn't, in fact, it's pretty different. What was the mean again? That was $527.86, wasn't it? That's $100 different. So they're both measures of central tendency, but we use different methods to find them. So now let's say you go back, you're going to order your tickets, and you discover that the $432 flight's no longer there. So you want to get the median price of the remaining flights. Instead of 7 in the list, now there's how many? 6. So if I throw out the 432 and I recalculate my median, let's see what you guys get. So this time, instead of one single value in the middle, I should have two data values in the middle. What are they?
397.
The 397 and the 427. And so if I average those together, Natasha, I think I heard you say it's how much?
No, I did not. That was too
Oh, you didn't? I'm sorry. Tiffany, you said,
412.
she said it was 412. Did anybody else get 412? Perfect. If you add them together, divide by 2, you get 412. All right, so it changed our median. It actually lowered it. Okay, last one. And we talked about this a minute ago. The mode, it simply means what? The one that occurs most often. Now, it's possible to have one mode, more than one mode, or no mode at all. All right, now how do you have more than one mode? Let's say that we had a list of airline flights, and there were 3 of them that were $425, and there were 3 of them that were $395, and there were others that were all different numbers. If it's a tie, I have 3 of this one and 3 of this one, then we say it's bimodal because there were 2 modes. If you could actually have 3 or 4 things that could tie for the mode. There's not a limit to having more than one mode, but what do you say if everything only occurs one time? If there's no mode, okay? You would have to have something that occurs multiple times for there to be a mode. Now, let's look back at these ticket prices. And if I were to ask you, and I believe this is our original list, because there's 7 flight prices in there, what would be the mode?
397.
All right, now I hear 397. I think it's Tiffany again. The rest of you need to start speaking up. Would you agree that 397 is the mode? Because why? The only one that occurs more than once. So 397 is the mode. By putting them in an order, it really helps you see it more easily. So 397 is the mode. Now, look at this. At a political debate, a sample of audience members was asked to name the political party to which they belong. So here are their responses. This is, I'm going to give you a heads up. Think about this before you answer. Be careful. What would be the mode of the responses? What would be the mode of the responses? The question was, what political party do you belong to? Okay. Now, if you think you know the answer, I'm going to see a hand. All right, so I've got one hand up.
Do we not have that?
No.
Do you not have that one?
No.
Okay, that's all right, because you're going to look up here and you're going to answer it. All right, so what would you say, Tamarian? He says the answer is Republican. Do y'all agree with him?
Yeah.
You know what? He is correct. Because a frequency tells you how many times you got that response. Which number is the largest? 56. And there was 56 people who said Republican. That was their answer, was either Republican, Democrat, other, or they just didn't respond. So the mode is going to be Republican. Makes sense? Got to be careful. That one, looking at just the table, is a little sneaky if you're not paying attention. Didn't trip up Tamarian. That's good. Now, all 3 measures describe a typical entry of a data set, but they each have advantages and disadvantages. The mean, we would say it's reliable because you use every entry of the data set to calculate the mean, right? It's kind of like how it's important that everybody has an equal chance at something. So we're using all of the values, but there are some disadvantages, just like we talked about earlier. If I were getting the average or the mean age of this class, you guys are so similar in age, that's an awful lot of work to calculate when it probably isn't going to be that meaningful compared to another way that I might be able to come up with a measure of central tendency. Here's the other disadvantage. It's greatly affected by outliers. Let's say, and you know, we had this happen last semester where somebody who's not a Terrell High School student wound up enrolled in this class, okay? Let's say that it was Grandma Jenny, who is 69 years old and is fulfilling her lifelong dream to go back to college. So if I have all of you guys in here who are 17, 18, maybe 19 years old, and Grandma Jenny, who's 69, when I take the mean of our class, is her age going to skew the data to be larger than what is representative of the class as a whole? Absolutely, that's what happens. So here's a little bit older version of our scenario. So you've got people in a class, and there's 20, 21, 22, 23, 24-year-olds, and Grandma Jenny, okay, who is 65. So if I were to ask you, what do you think would be the best way to describe a typical entry of this data set? Would you choose the mean?
No.
And the reason is Grandma Jenny. She's an outlier. She's going to skew the data. What do you think about the median? Would that be a good way to describe the data set? Well, the median means we would do what? Find the middle. In fact, are these already in order from least to greatest?
Yeah.
If you go across the rows, it is. So can you real quickly kind of figure out what number would be my median? Okay, I hear a 21.5. Did you calculate it or are you guessing? Okay, he calculated it. So you said we had 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17. Yeah, there were 20 values, so that meant the two in the middle had to be averaged. He got 21.5. Do you think that might be a pretty good way to describe the typical entry in this class? It definitely sounds like it's probably a better option than the mean. What about the mode? What would you tell me the mode is? The number that occurs most often is 20. Would that be the best description for a typical entry in this class? That's actually the lowest value. So does it describe most of the people in the class? It describes what occurs most often, but is it, would you say it's typical for the class? Do you kind of, okay, so let me show you this and see if this helps. All right, if you actually put Grandma Jenny's age in there, average it up, you get 23.8 years. Now, if I look at all the ages in the class, 23.8, I've got 3 people older than that, and I've got 17 people younger than that. Does that sound like a good description of the class? I don't think so. It's on the high side compared to what most of the class is. The median was 21.5 because we averaged 21 and 22 together. Those were the two values in the middle. The mode is 20. And even though I have more people in the class who are 20 than any other age, it is the youngest of anybody in the class. So if you were to look at this graphically, okay, this is what you would see. My mode, it does occur most often, but it's at the very, on the far left side of this, if I were to graph the frequency of these ages that occur. My mean is going to be further on the right side of the graph because it was 23.8 because it was influenced by that outlier. Where does the median fall? In the middle. And it would be more representative of the class as a whole because it isn't affected by the outlier, but we still took in every age in the class to calculate the median. You see what I'm saying? That makes it the data entry that would represent the most, it'd be the most typical data entry. All right, everybody would relate closer to the median as a whole than they would to the others. All right, you want to get something that's not going to be affected by outliers, and that means if there's an outlier, don't use the mean. Okay, If your mode happens to be something that is clustered at one end of your data or the other, you probably don't want to use it. The median would be a better option. Okay? Now, you guys know how to find a weighted mean? Have you ever had to calculate your average in a class? Oh, yeah. Think about it. You've got groups, and they have different weights. For instance, in this class, your tests count 60% of your grade. Your homework and quizzes together are 20%, and your final exam is 20%. Okay? So if you have a test average and you have homework and quiz average and you have your final exam, you would use those weights to calculate your final grade. Now, if I say, have you ever used a weighted mean? You say, yes. Okay? So this would be the formula for a weighted mean. Because it's a mean, we're using X bar, all right? And remind me again, what is this letter called right here? Sigma. And it means to do what? Add. This is telling me I would have to take the data entry times whatever its weight is. And I would do that for each of the entries, and then I add those up and divide by the total number of the weights. Now, the easiest way to do that, because if I am calculating at the end of the semester and it's 60% test, 20% homework and quiz, 20% final exam, I'm going to take your test average and multiply it times 0.6. And then I'll add to that whatever your homework quiz average is times 0.2, and I'll add to that your final exam times 0.2. Now, if I do that, I've done everything up here in the numerator. What is the sum of the weights? What do you get if you add up 60% plus 20% plus another 20%? 100%, which as a decimal number is 1. I don't have to divide by anything if my weights add up to be 100%, okay? So we're going to see if you guys can do this. Find a weighted mean. You're taking a class. Your grade is determined from these sources. Here are your percentages, and there are the grades. Can you figure out what your average is? And if the minimum average for an A is 90, can you tell me if you got an A? So you're going to complete that, and when you're done, you guys get to go. Okay, so once you have calculated those, you can see that you will take your category, whatever the score is, times the weight, and because the sum of all the weights is 1, when you add up everything over here, that would be your final grade, 88.6. Unless the professor is very generous, he doesn't get the A.